Do you feel the vibes?
Right, so a matrix is a rectangular array. An array is just like a rectangular way to sort information. And a matrix can include variables or constants, and they're arranged in rows and columns, right? Enclosed in brackets. Now, each value inside a matrix is called an element. Okay? Okay, now, in here, right, you have rows. The rows go horizontally like this. So you have 1, 2, 3 rows. And then you have 1, 2, 3, 4 columns. Okay? Now, the dimensions of a matrix is basically the size of a matrix. And it's given by m rows and n columns in that order, written as m by n, right? So in this case, we have 1, 2, 3 rows, 4 columns. So this is how the dimensions are given, but it's read as 3 by 4. So obviously, if you mess that up and if you say 4 by 3, it's a completely different looking matrix. Okay. All right. Now, each one of these elements has a name by the place where they're situated. So for example, I can either call you guys by your names, or I could call you by your seats, right? So I can say, for example, hey, 1, 1, right? Or 1, 2, right? Or 2, 2, or 2, 3, exactly, right? So the way you name a matrix is with a capital letter. So this one, for example, is matrix A. And then each element inside will be labeled little a, and then the place where they sit. So first row, first column. So this one is little a, first row, third column, A1, 3. And then if you go to the really big matrices, you can separate with a comma if you get into double digits and so on. So what would this -8 be called? A what? Which row? 3, second column, 2. Okay?
It's not 32.
No, it's A32. That's how you do it. That's how you say it.
That one,
Okay, so let's let's go here. Here's example 1. You have a matrix A. We want to find the dimensions of A, right? A has 2 rows and 3 columns, so it's 2 by 3. And then find the value of A23. So the second row, the third column, that's -8. This one. Okay? All right. Let's talk about some terminology. A row matrix is a matrix that has just one row, right? Like this one row. You could have as many columns as you want, but just one row. So what are the dimensions of this matrix here? 1 by 4. A column matrix is a matrix with 1 column. What are the dimensions of this matrix? 2 by 1. A square matrix just has equal number of rows and columns. So in this case, this is 2 by 2. It could be a 3 by 3. It could be a 5 by 5, or it could be an n by n. Okay. A zero matrix is a matrix of any size, but every element inside is 0. Okay? What's the size? What's the dimension of this? 2 by 3. Okay. An identity matrix is a square matrix in which every element on the main diagonal is 1. So let's just see where the main diagonal is. This is the first element here, right? 1, 1. If I take that diagonal, right, that is called the main diagonal. So in the identity matrix, every element on the main diagonal is 1, everything else is zeros. Right? That's an identity matrix. Okay, it could be a 3 by 3, it could be a 7 by 7, whatever. All right, questions so far? Okay, so let's talk about matrix operations. Matrices can be added or subtracted, but only if they have the same dimensions. So a 2 by 2 with a 2 by 2, a 3 by 5 with a 3 by 5. The reason for that is the following. When you're adding two matrices, the result is also a matrix of the same size. So if I have a 2 by 2 and a 2 by 2, the sum is another 2 by 2. So the way I add is the following. I take the first one here, the one in the same position here, I literally just add up those two numbers and I put the sum in the same position, right? So straightforward. If I took this one, I take the one that corresponds, sum goes there, all right? This one goes there. That's why they have to be in the same dimensions. All right, so take a look here. We've got A, B, and C matrices. We want to find the following. Okay, A plus C. Not possible, right? Because they don't have the same dimensions, correct? A and C, so not possible. It doesn't matter. B minus A. Okay, so B and A do have the same dimensions. But you know what? We're going to rewrite them here because we're not going to take any chances in crisscrossing our numbers. So that's B minus A. These are each 2 by 2s. I'm going to make another matrix that is also a 2 by 2. So now look, let's take the first ones. 10 minus 2, 8. Negative 2 minus 5, negative 7. Negative 3 minus negative 1, negative 2. 16 minus 3, 13. Right? I mean, how straightforward is that? Right? See? Not scary at all. Okay. So, in the world of matrices, the matrices are kind of the VIPs. And then, second to them are these things called scalars. Scalars are just the regular old numbers that you all know and love, but they just haven't been elevated to matrix status, right? Okay. You can multiply a matrix by a scalar, by a regular number. When you do that, each element in the matrix is multiplied by the value of the scalar. So take a look at this one. This is the matrix, clearly. Negative 3 is not a matrix. It's just a number on its own. It's called a scalar. When we multiply the matrix by that scalar, literally every single number is multiplied by that number. So in my matrix, I get negative 3 times 1, negative 3. Next to it, negative 3 times 5, negative 15. What do I get in the second row? And bottom, and negative 12. Right? I mean, listen, this is just so much fun. I know. Well, wait, we're not done yet. Okay. And then you could do some more complex operations. So you could, just like numbers, A plus B, B plus A are the same. You can add 3 to each other. And then you can also add two matrices and multiply by a number, just like you do with anything else, any other algebra. So take a look at this. We want to find 3 times A minus B. So this is 3 times What's A? This one. Minus this one. Cool? So this is 3 times. And so now we're going to subtract these two matrices. All right? So what do I get in the first row? 4, -2, -1, -2, 1, 0 minus 3, -3, 3 plus 1, 4, 2 minus 6, -4. Is that right? Yes. Then we're going to multiply the 3 into this. So, all right, I'll race you. Are you ready?
Yeah,
On your mark. Wait, don't start yet. Wait, no. I don't want to give anybody a head start. So they're... Oh, wait, it's a race. On your mark, get set, go. I'll answer your question later. Okay.
Are you over multiplying?
Yep. Okay. Somebody check my work. I mean, I'm hoping you wouldn't need to because it slows you down. But, okay. All right, what was your question? Okay, so I'm going to give you 3 minutes to do this one. So you're going to do 2a plus b, right? 2a plus b, meaning first we're going to multiply 2 times a, and then we're going to add to that b. All right, and again, this is a race. Ready, set, go. Oh, so unfair. Okay. Okay. Who's done so far? Okay. All right, let's compare. Let's compare. Did you guys get this? Okay. All right. Plus 2a plus b. 2a plus b. Okay, we're good.
I thought the 4 euro.
All right, let's do 3b minus 4a. So 3 times b, that is 3 times this column matrix, minus 4 times the other column matrix. So this is, right, when I multiply 3b, -6, minus 12, 4a. Okay, so now we're going to get another column matrix. Okay? So 2 rows, 1 column. So on top, I get 3b minus 12. That's in 1 slot. And then -6 minus 4a. Right. -6, yeah, or -4 minus 6. Okay? So again, that's just 1 column. Okay? All right. So on the next page is an application. One, very simple example. This table shows the highway and city gas mileage, right, the MPGs, of 5 different types of vehicles. So you've got SUV, minivan, sedan, compact, and this is a like all-purpose vehicle, like okay. All right, and we've got the city miles. So, for example, the minivan gets 21 miles per gallon in the city, 24 in the highway. Organize the gas mileage in a 2x5 matrix. So when it says 2x5, it's clear. There's only one way you can do it. 2 rows, 5 columns. And in the matrix, you can only put values, no descriptions. No. You just copy them inside a matrix. So now this is a 2x5. And I know, right, what it stands for, right? Because, I mean, the purpose of it is the same. It's just now, you know how like in like word problems, when you're looking at like the distance to a tree, you know, whatever, like you can either do like the picture of a tree and a cat sitting in a tree looking down, whatever, or you could just translate that into a diagram of just a triangle. Right? This is kind of the difference, okay? All right, so right now it says add the elements in each row and interpret the results. Do they present any relevant information? So if we add the elements in the top row, right, you get 20, 40, 60, 120, 160, 168, right? Okay, and then all of them, just add them up. And then what do we get here? I lost count when I had the question. 200. Okay, so now the question is, do these represent any relevant information? So this is basically the sum of the miles per gallon in the city for 5 different cars. Is that any meaningful information to us? Is it? Is it though? It's really not, right? Because who cares? Who cares like how many total right? So this is not any relevant information. So now, compared to, right? Compared to, if, for example, you subtracted values from 2 columns, right? 23 minus 21, you got 2. That is something usable because that's like, oh, okay, so the difference in miles per gallon between the SUV and the sedan is 2, right? So the purpose of this, I know it's kind of like open-ended. The purpose of this is just to say, okay, you added these. What exactly is it that you found? And we know that what we have found is just the sum of all of the miles per gallon for all of the cars, okay? All right, so this is where we're going to stop today. So just basically like, this was just introduction to terminology and all of that.
Press start.